Claude models are extremely good for all software workflows, but are they really good at solving electrochemical problems? Let's find out. Hi everyone, I'm Gaurav, and I have spent the last 15 years doing R&D and advanced manufacturing in semiconductors, batteries, sensors, all kinds of material science. In this video, we will go through electrochemical workflows using Claude and Gemini. And we will find out how good these agents are at understanding electrochemical context, producing outputs that can actually be useful, and can we use these agents in production or not. I will also show you how to use these tools reliably using a harness like Niobia AI that makes Claude more token efficient and reliable. To start the analysis, I gave Claude a relatively easy problem. Two cells, one is definitely worse performing than the other. I asked it to compare the discharge profiles and capacity retention and plot the DQ/dV curves. I also asked it to remove the outliers and find why one cell is performing better than the other. Claude did a lot of thinking, and I'm going to talk about that in a little bit, but it did remove the outliers properly, and it created this nice table of what the key parameters, key metrics I want to see are. Definitely highlighted that one cell is much higher capacity than the other. Since we are using the same current on both of them, we automatically are charging one cell at a much higher C rate than the other, leading to the resistance differences as well, and that is the key reason the cells are failing. So it was actually good in the electrochemical reasoning around why the cells are failing. Yeah, so I'm happy with the electrochemical analysis. Let's look at how presentable the outcome is. This is where my first problem comes. It made up a PNG. I do not think I can edit this at all. I can't even zoom in, zoom out to actually find out what is happening. The axis is labeled in very small fonts, which I cannot change. The worst one is the DQ/dV analysis. There was definitely an outlier in this profile. It did remove the outliers, but it has not auto-scaled it. So overall, I can't use this output. I have to go back and forth to get better outputs from this model. I would say though that I have used Claude extensively, and it does give much better results in general, but it's just not consistently giving me those results. I'm going to give you an example of that right now. Here, I changed the prompt a little bit. I asked it to just compare the profiles and show the capacity retention with the same exact files. Here, it did give me a much more interactive file, which here in the DQ/dV curve, I can actually see that there's a voltage difference. There's a voltage shift between the two cells. It's a JSX file, so again, I don't think I can just export it and use it for other things. I can publish it as an artifact or download as JSX. One key thing that I want to flag here is that this analysis took me 8 minutes to run. On the other hand, I also did a parallel analysis in Niobia AI platform. I had the same Claude model, I had the exact same prompt running here, and this ran in 2 minutes. And I was trying to find out why did this happen in 2 minutes, and this took like 8 minutes. And when I started digging deeper, I found out that Claude had done a lot more to actually get this file done. It has built data structures, it has built parsing tools, it has built an entire electrochemical software suite basically to do this one analysis. It has multiple packages that it had to download. So think of it this way: you have to go from point A to point B, and Claude builds you a car from scratch to go from point A to point B. It's great at building that car, but there are 3 problems here. Number 1, nobody has verified that whether the car works properly or not. Is it safe or not? There's no expert verification of what it built. Secondly, we don't know whether it can build it reproducibly or not. I have seen with my personal experience, there are many times variations between what it does, and everything depends on the wording of your prompt. Your prompt has to be on point for it to make really good stuff. Okay. And number 3, the amount of tokens it uses to do these analysis is insane. I consumed my entire free plan to build this, and honestly, currently we are all on subsidized tokens, subsidized by the VC money of Anthropic and OpenAI. When push comes to shove, and we are dependent on these tools, the cost of these tokens are going to increase a lot. We should make sure that we internalize habits on how to efficiently get our work done and not throw tokens at the problem. And that's exactly why we built Niobia AI. In Niobia AI, we built batteries and the material modules specifically so that these Claude does not have to build everything from scratch every single time. We have built hundreds of tools that Claude can use and do things much faster, be much more token efficient, and most importantly, more accurate. We don't let Claude just go and do any analysis it wants. Claude is bound by the tools that we have built for it, and if it's doing any material chemistry analysis, it has to use these tools, right? So that makes it much more accurate, and it's expert validated tools that Claude can use. I want to be able to zoom into things and be able to see what's happening here. In terms of electrochemical reasoning, it's very aligned with Claude because it is using Claude 4.6 on its models. It is pointing at the internal impedance, voltage hysteresis. For the capacity multiple, it is pointing towards active material or electrode area issues, which is one level deeper than Claude because the agent already knows most of the failure modes in electrochemistry and battery chemistries. I also wanted to test the exact same workflow with Gemini because I know most people already have Gemini subscriptions. It's widely used in corporate world. But with Gemini tool, I did see DQDV, nope. Even the voltage profiles, it didn't understand that the voltages have to start from 0. It just used the native Arbin timestamps to calculate discharge capacity, and it did not start from 0. The worst one is this capacity retention plot. Arbin files, if you know, have a column called discharge capacity, which is actually just a cumulative discharge capacity. It just blindly took that discharge capacity without even verifying. So this is completely wrong. And based on that, all the analysis that it did is also wrong. The only thing it got right is the internal resistance thing. So Gemini is not great at electrochemistry natively right now, but if you give it the right tools and the right harness, even when we used Gemini 3.1 in Niobia AI platform, it was able to give us a good capacity retention curve, voltage hysteresis, and DQDV curves. Even the failure modes, it was able to pinpoint at loss of active material and internal resistance as the key reasons for one cell performing worse than the other. This was an example of a simple electrochemical workflow. In the next upcoming weeks, we are going to test much more complex multi-step workflows from electrochemistry and broader material science. To sum it up, Claude is natively really good at electrochemical and material science workflows. But if you use it with a harness like Niobia AI, you can really make the workflows much more repeatable and token efficient. Please let us know if you would like to see any other electrochemical workflows or material science workflows in general. Have a nice day.